Hello students. In the previous video, we solved part A of model question paper provided by Department of Pre-University Education. If you have not seen it, see the part A first and then you watch this video. The link of that video is given in the description. You can use that link and watch the solutions of part A. So now in this video, I am solving the questions of part B. So in part B, there will be 2 mark questions. Okay, see, answer any 5 of the following questions. So 5 questions, each question has 2 marks, so total 10 marks. In the previous year question paper, means according to previous pattern of question paper, there used to be 8 questions here and you had to answer any 5. But now more choices have been given. Okay, 10 questions are given and out of 10 you have to answer any 5 questions. So now we will answer all these 10 questions. Okay, so let us take the first question. Write any 2 differences between polar and non-polar molecules. We have to write the differences between polar and non-polar molecules. Okay, so to write the answer, just a minute. Okay, so we have to write the differences between polar and non-polar. So make 2 columns. Polar molecule, non-polar molecule. First point, polar molecule. In polar molecule, the centers of positive and negative charges are separated. The center of positive and negative charges are separated. In a non-polar molecule, the centers are not separated. The centers of positive and negative charges are not separated. Okay. Then second point, polar molecules have permanent electric dipole moment. These have electric dipole moment. These molecules, because here positive and negative charges are separated, therefore each molecule acts as an electric dipole. Therefore each molecule has a dipole moment. Here both positive and negative charges are not separated, they are coinciding. So they don't have, these molecules, these have no dipole. These molecules don't have dipole moment. So these have no electric dipole moment. So these are two differences between polar and non-polar. If you want, you can write example also. One more point you can write. Example for polar molecules are H2 and HCl. And here the examples are O2 and H2, hydrogen molecule and oxygen molecule. This is the answer. Now the next question. State Ohm's law and write its one limitation. Ohm's law. It is very important law in current electricity. So according to Ohm's law, answer Ohm's law. According to Ohm's law, the electric current through a conductor current through a conductor is directly proportional to proportional to directly proportional to potential difference across the conductor. Okay. Yes. The electric current through a conductor is directly proportional to potential difference across the conductor under constant physical conditions. So this law is applicable only under constant physical conditions. Okay, this is Ohm's law. Then write is one limitation. Limitation. Limitation means shortcoming where this law is not applicable. So first one, this law is, they have asked any one. I will tell you many. You can write any one of them. Okay. I will tell you two or three. So first one is this law is not applicable at very high temperature or at low temperature. This law is not applicable at high or low temperature. At very high or at very low temperature. Okay. And second one, this law is not applicable if physical conditions are not constant. This law is not applicable if physical conditions are not constant. And this law is not applicable for some substances, semiconductor devices, like it is not applicable for semiconductor devices. Semiconductor devices means diodes, okay, then transistors, such devices. For such devices, this law is not applicable, and it is also not applicable for electrolytes. So these are some limitations of Ohm's law. You can write any one limitation. Next question. Define magnetic declination and inclination of the earth. Okay. Define magnetic declination. So first let us define declination. So what is declination? It is the angle between angle between geometric meridian and magnetic meridian. At a given place. Some place on the earth. Okay. Yeah. Then what is inclination? Inclination. It is the angle between total magnetic field of the earth. Total magnetic field of the earth and the horizontal. In the magnetic meridian. Okay, it is the angle between total magnetic field of the earth and the horizon. The next question. Draw a typical hysteresis loop for a ferromagnetic material. Mark coercive fields in it. Hysteresis loop means when a ferromagnetic substance is taken to a cycle of magnetization, the graph obtained, the graph of H versus I, is called a hysteresis loop. So here H, let us take it along x-axis, it is applied magnetic field, and I, it is magnetization produced in the substance. Okay. Initially, when H is 0, I is also 0. Now, when we increase H, I also increases and reaches its maximum value. Now we start decreasing H, and I also decreases. When H is decreased and it becomes 0, I is not 0. It reaches point A. Even when applied field is 0, magnetization has still some value. Okay. Now we start applying the magnetic field in reverse direction. When we apply magnetic field in the reverse direction, magnetization decreases and it becomes 0 at point B. Now we continue increasing the magnetic field in the reverse direction, then magnetization also increases in the reverse direction and reaches a maximum value. Now we start applying the magnetic field in positive direction, then magnetization also increases in positive direction, and finally it reaches the initial point. So in this way, here a loop is formed and this loop is called hysteresis loop. So this is hysteresis loop. Now the question is mark coercive field in it. Coercive field means what? Coercive field means it is the, see, as I told you, when we decrease the magnetic field, magnetization decreases. But when magnetic field becomes zero, magnetization has still some value. This is called residual magnetism. Okay, so to make this residual magnetism zero, we have to apply the magnetic field in the reverse direction. So the applied magnetic field in the reverse direction to make magnetization zero is called a coercive field. Here OB represents coercive field from O to B. This is coercive field. So here we will write it. OB represents coercive field. So coercive field means it is the negative magnetic field to make magnetization zero. Okay. Yes. Next question. Let us take next question. Next question. Question number 20. What is the displacement current? Write its expression. Yes. The current in a region here, or in a region here here there is changing electric field. This is called displacement current. Okay, the current which appears in the region where electric field is changing with time is called displacement current. The current in a region where there is changing electric field is called displacement current. And the expression for displacement current is ID is equal to epsilon naught d pi by dt, where pi is electric flux and the epsilon naught is permittivity of free space, where epsilon naught is permittivity of free space, and pi is electric flux. Okay, now let us move to the next question. Question number 21. Write the two conditions for total internal reflection to occur. Total internal reflection means when light falls on any smooth surface, it bounces back. The bouncing back of light when it falls on a smooth surface is called as reflection. It's called reflection, but total internal reflection of light. Next question, question number 21. Write the two conditions for total internal reflection to occur. Now, what is total internal reflection? When light is moving from denser to rarer medium, as we go on increasing the angle of incidence, at a particular angle of incidence, the light starts grazing the surface separating the two media. When we further increase the angle of incidence, the light bounces back into the first medium. This phenomena is called total internal reflection. Here question is, write the two conditions for total internal reflection. So the first condition is light must be traveling from denser to rarer medium. Total internal reflection takes place only if light is moving from denser to rarer medium. You cannot, total internal reflection cannot take place if light is moving from rarer to denser medium, because when light moves from rarer to denser medium, an angle of refraction will be lesser than angle of incidence. So total internal reflection is not possible. And second condition is the angle of incidence must be greater than critical angle. So these are the two conditions for total internal reflection to take place. Now let us take the next question. Question number 22. Write any two uses of polarides. Any two uses of polarides. Okay. The first important use is polaroid is used to produce polarized light. It is used to produce polarized light. Second, it is used in window shield. Or window glasses. And they are used to watch. Polaroid is used to watch 3D movies. So these are some uses. They have asked any two, you can write any two uses. Okay. Yes. Now the next question. So find the potential difference through which an electron be accelerated so that its de Broglie wavelength becomes 0.1227 nanometer. Okay. Find the potential difference through which an electron be accelerated so that its de Broglie wavelength becomes 0.1227 nanometer. Okay. See, we know that the de Broglie wavelength is given by lambda is equal to h by square root of 2m e h is Planck's constant, m is mass of the electron, e is charge of electron, and v is potential difference. Okay. Yes. Now wavelength is given, lambda is given here. Then what is potential? We have to find the potential difference. That is V. We have to find V. Okay. So here, if we put the values of this constant, H is Planck's constant, its value is 6.627 into 10 raised to minus 31, and m is mass of the electron, its value is 9.1 into 10 raised to minus 31 kg. E is charge of the electron, its value is 1.6 into 10 raised to minus 19 coulomb. If we substitute all these values and simplify, we get 1.227. You remember this directly, okay? 1.227 divided by square root of V. We substituted all the values of all these constants M, E, H in this constant 2. So then we will get 1.227 by square root of V. Okay, you remember, it will help you for faster calculation. Okay, now we have to find V. Okay, therefore from this equation we can write square root of V is equal to 1.227 divided by lambda. I send this square root of V to this side and lambda here. Now then 1.227 divided by lambda. Lambda value is 0.1227. Okay, so this will become 10. This is 1.227, it is 0.12227. Okay, so we get 10. But it is square root of V. Okay, so to remove this square root, we have to square. Squaring on both sides, we get V is equal to 100. So 100 volt. This is the potential required to produce this wavelength. Okay. Yes. Let us take the next question. Question number 24. Write any two limitations of Bohr's atomic model. Okay. Limitations of Bohr's atomic model. First limitation. First one. It is applicable. It is applicable only for hydrogen-like atoms. Hydrogen-like atoms means hydrogen-like atoms means atoms containing only one electron. If an atom contains more than one electron, then this postulate cannot be applied. Then second one, it does not explain. It does not explain fine structure of spectral lines. So these two are the limitations of both postulates. Then next question, question number 25. In the following circuit, if A equal to 1 and B equal to 1, what is the value of Y? Name the equivalent logic gate that this circuit represents. Yes, here one logic gate is given. So logic circuit is given. We have to find the output here, Y. A and B values are given. A is 1 and B is 1. See, you observe this. This one is OR gate. This is called OR gate. So OR operation is plus. If inputs are A and B, then output will be A plus B here. So A is 1, B is 1. 1 plus 1 means here you will get output as 1. And this one is a NOT gate. NOT gate means it reverses. Reverses the input. Therefore, here you will get Y is equal to inverse of this. Okay. So here A plus B will be 1. So its inverse is 0. So output will be 0. Okay. Yes. Now then this is first part. In the following circuit, if A equal to 1, B equal to 1, what is the value of Y? So the value of Y is 0. Then second, name the equivalent logic gate. See, here this is the combination of OR gate and NOT gate. So OR plus NOT, it becomes NOR gate. So the equivalent logic gate is logic gate is NOR gate. Okay, yes, this is the answer. The NOR gate means its symbol will be like this. We have to put one vowel here. OR gate, and then this is the symbol for NOR gate. But this is not required. Here they have asked only name the equivalent logic gate. So the equivalent logic gate is NOR gate. This much is enough. This is for your additional information. Okay. Yes. Thank you. So here we completed all the questions from part B. Okay. I hope it is useful for you. You like this video. If you think it is useful for you, then kindly subscribe to this channel. Okay. In the next video, I will solve the remaining questions. Okay. I will solve part C. In part C, there will be 3 more questions. Okay. So in the next video, I will solve 3 more questions. If you want to see that video, so don't forget to like and subscribe to this channel. Okay. Thank you.